Here's our notes. Geometric series. The sum of a sequence. That's what the word series means. I'm adding together my list of numbers. So for this, I have a formula. And I'll expand this. I have lots of space. Okay. I'll have to do each example one by one for me clean up a little bit. Here we go. So I'm adding together all my numbers. Let me explain what each part of this formula means. This is the sum of my list of numbers. A sub 1 is my first term. The R stands for my ratio. And the N is the number of term that I'm looking for. Like it says, find the sum of the first 5 terms. So I would write my exponent to the 5th power. The number I'm adding to, or like the term I'm finding the sum of. These are very wordy, but. So if I want the first 8 terms, then my exponent would be an 8. Consider the geometric series. 4 plus 8 plus 12 plus 32 plus, okay. So my first term is obviously 4. What am I doing? I'm multiplying by something. I know that there's an addition problem, an addition sign, but from 4 to 8, what am I going? Like, what is it? 4,
Ms. Grant?
8. Yeah.
I don't think your camera is showing us that. All I see is the paper that had number 20 on it.
And you're right, because I didn't switch it. Does your guys just say 4, 8, 16 or 4, 8, 12, by the way?
4, 8, 12.
Yours says 4, 8, 12? Okay. Thank you for saying something, because that means that I've been recording and you've been staring at the worksheet. Okay, here's what I want to do. I want to switch it and I want to make this be 4, 8, this is a typo, 16. That's a typo. I did not change that in the worksheet and I should have. Let me just do that now, actually, because it's a Word document. Okay. So now it says it. Can you please change that on your paper? So now it's easy to figure out. The plus sign should not confuse you. It's just this. But the sum means that I'm going to add them. So what's my ratio? What am I doing to get from 4 to 8 and then 8 to 16 and then 16 to 32?
It's getting multiplied by 2.
Multiplied by 2. My ratio is 2. Now I'm asked to find the sum of the first 5 terms. So the sum of the first 5 terms is going to be this formula up here. My first term is outside the parentheses. My first term is 4. And then I have a fraction inside. My numerator is 1 minus my ratio raised to the number of term I want. My ratio is 2. So 1 minus 2 to the 5th over 1 minus 2. So this isn't horrible. 2 to the 5th is the only thing you need to do. You can do it in your head. But, right? 1 minus 32 over negative 1. And 4 negative 31 over negative 1. Uh, 31, right? The sum of the 5 terms is 124. So, do you need another second to copy that down? Okay. I'm going to scroll down to example 2. Okay. So, here we go. Let's write the formula on top, just in case. Or is this on the same page for you guys? Or did you have to turn the page?
I have to turn.
You have to turn the page. Ready? Sum of the numbers equals a sub 1 times 1 minus r to the n divided by 1 minus r. Okay? That's my formula to find the sum of a geometric series. Example 2 has 2 plus 6 plus 18 plus 54. Okay. What's my a sub 1? What's my first term in my series? Someone. It's like the easiest question ever. What's the first number that you see on my list? Wow. Yes, Marcos.
2.
Thank you, sir. My ratio. 2 becomes 6. How? 6 becomes 18. How? 18 becomes 54. How?
3.
3. Here we go. My sum of my 6th term. Find the sum of the first 6 terms is the question that I'm asked. First term times the quantity. 1 minus 3 to the 6th over 1 minus 3. I'm short on space, so um, 3 to the 6th is 729. You can do it on your calculators. You should have your calculators handy. Okay. 2 times times negative 728 divided by negative 2? Can someone do that first for me? How many times is 2 going to 728?
364.
Okay, 2 times 364. Back to 728. Because that's the thing. If I divide by 2 and then multiply by 2, I'm back where I started. I could have simplified these 2's here. That would have made it like one step quicker, right? I could have simplified these 2's right here. Copy that down on example 2. We're really close to being done. But example 3 has a special notation, that Greek letter. That Greek letter is the letter E in the Greek alphabet. But we say the word sigma. So I'm gonna there's another, well, it's actually, it's sigma. Okay, sigma. It's not E. I was wrong. E is epsilon. Sorry. Okay, here's what everything is. When you see this symbol, it means sum. You're going to find the sum of something. And then there's all these numbers. There's a number on top. There's a number below. This number on top is going to tell you how many terms I'm going to go for. How many terms I'm going to find the sum of. I have to find the sum of 30 terms. Find the sum of the first 30 terms. That's why the 30 is on the new on top. N means first term, or plug 1 in. Usually you'll see a 1 there. If it's a 2 or a 3, that means that you plug a 2 in. This is my actual equation. I want to let you know that 27 means A sub 1. 1/3 is my ratio. A sub 1 is 27. My ratio is 1/3. I don't know the sum of my 30 yet. Okay, here we go. I'm going to use this information here. The N is the number that I'm plugging in. It tells me at the bottom of the sigma symbol. So I'm going to go. A sub 1 is 27 times 1/3 to the 1 minus 1. This 1, this N, came from here, right? 27 times 1/3 to the 0 power. 27 times 1. My first term is 27. A sub 1, 27. But I knew that from my formula. Plugging in, now I continue on, and I'm gonna have to do this 30 times because it says plug in 1, but I need to know 30 digits, and I'm gonna add up 30 digits of this list. I'm only gonna find the first 3 terms. I'm only gonna do 3 with you right now because I was asked to find the first 3 terms. 2 means that I'm going to plug in a 2 minus 1. Third term means that I plug in, a 3 minus 1. One-third squared is 1/9. 9 goes into 27 3 times. So I found my first 3 terms. Done. Find the first 3 terms. I did. Now, find the first 30 terms. Somebody tell me what I'm going to do with the number 30. I'm not going to keep doing this 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. No, 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 no. Someone on Zoom, tell me, what would I do if I wanted to know the 30th term? Look at my black. Oh, go ahead.
27 times 1/3 to the 29 power.
Yep, you plug in 30 for n. (30 minus 1). Okay, guess what? 1/3 to the 29th power. Hold on. Sum formula. It's on the top of your paper, right? Hold on. Okay. I don't want to know what the 30th term is. I want to use my sum formula to find all of them added up. 27 times 1 minus 1/3 over 1 minus 1/3, but this one's to the 30th. So fix that. Sum formula. This formula tells me what is the number that is the 30th term. But if I want to be adding as I go, I have to use my sum formula. Okay, 1/3 to the 30th power is crazy. It's 1 minus, it's scientific notation, 4.857 times 10 to the negative 15th. over 1 minus 1/3, that's 2/3. Ha ha ha. 1 take away 4 and 856 thousandths times 10 to the negative 15th. I am not going to move my decimal 15 spaces to the left. But this is what your calculator would say. So I'm just kind of making sure we're good. It is like 0.00000000, right? So I'm just gonna basically do 1 minus 0. Because if something has 15 or 14 zeros in front of it, it's worth nothing. (27) times 1 minus 0, because our scientific notation number is really 0, over 2/3. How do I get rid of the 2/3? Because right now I can't touch the 27 and someone else, because you help. How do I get rid of a 2/3 in the denominator? This is what the math problem says, you guys. 27 times 1 over 2/3. How do I get rid of that 2/3 in the denominator? How do I get rid of a denominator that's a fraction? Oh my gosh, guys, the denominator is a fraction. I need to get rid of a fraction in the denominator. Multiply by the reciprocal, 3/2 on top and bottom. So I've got 27, the 2's are gone, the 3's are gone, the denominator's gone. That's how I get rid of the denominator, by multiplying by the reciprocal. Now I have 1 times 3/2. Well, that's just 3/2. 27 times 3/2. Uh, 81 over 2, 40.5, 40 and a half. The sum of my first 30 digits is 40 and a half. Okay. So let me stop the recording. I'm going to do a couple practice from the homework.